All right, so today we are in day 1 of inequalities, writing and graphing. All right, the first thing we need to know is what an inequality is in the first place. Okay, it's a mathematical sentence that compares expressions. All right, so an inequality is always a comparison. We'll talk about that more in a minute. The solution of an inequality is the value that makes it true. Okay, and then we need to know some symbols. So I just want you to star this, highlight it, circle it. We're going to come back to these symbols when we start graphing inequalities. This is what we call an open dot, and we use an open dot to express less than or greater than. We use a closed dot to say less than or equal to or greater than or equal to. All right, so just some general terms and definitions here. All right, before we go on to the next slide, I want to talk about the difference between an inequality and an equation. Okay, let's start with the equation. How would I solve for x? Y'all just tell me. How would I solve for x? You would divide both sides by 3. Okay, and x equals 5. Would you agree that 5 is the only value that can make that equation true? 3 times 5 is what? 15. Can any other number be multiplied by 3 and equal 15? No. So equations have one solution and one solution only. Okay? Now, we solve inequalities the exact same way we solve equations. So, in order to solve this, I would divide both sides by 3 again, right? But now look what happens in my answer. The x, when we read our answer, I want you to say all numbers, okay? The x stands for all numbers, all right? So here we go. We're going to say all numbers, say it with me, all numbers less than 5 make the inequality true. All numbers less than 5 will make the inequality true. Give me a number less than 5.
4.
2. 4. 1.
3.
Okay, yeah.
0.
Go lower.
-7.
Yes, negatives. -7. Okay.
4.9.
-12. Well, let's just stick with integers. Okay, let's not get crazy with it. All right, so now look here. You can take any one of these values and plug it in for x up here. Okay, let's just take our first number, 2. 3 times 2. What's 3 times 2, guys?
6.
Is it true that 6 is less than 15? Yeah. All right, let's do another one. 3 times -7. What's 3 times -7?
21.
-21. Is it true that -21 is less than 15? The notes are on the top shelf over there. You need to hear this, so I would just grab the notes and get it in a sec. Okay, so here's what we know about inequalities. There are many, actually infinitely many solutions, the right side, to inequalities. There's not just one solution. Do you get that? Do you see that, guys? Literally, we just made up 6 different numbers, and all of those numbers would make this true. Okay? All right, so that's the main difference that we see between inequalities and equations. So, let's now talk about writing a sentence or a statement as an inequality. Well, we need to know our key words here. So let's read the first one. It says a number b is fewer than 12. Fewer than 12. What phrase in that statement do you think would tell you what symbol belongs in the inequality? What phrase do you see there? Tell me. Fewer. Fewer than. Okay, so b is my variable, and I would say b is fewer than 12. Okay, that one's pretty simple, right? It's not too bad. Before we go any further, let's talk about our key words here. We have less than, greater than, less than or equal to, and greater than or equal to. Here's our 4 symbols. Okay? So for less than, we just said fewer. Fewer than was one keyword for less than. What about just less than? Right? Okay? So for greater than, yep, we could say greater than. We could say more than. All right, then we have less than or equal to and greater than or equal to. But I want to talk about 2 phrases that are often confused. What about at least? Which one of these 4 symbols do you think means at least? Okay, don't say it out loud yet. Okay. It's kind of hard to know, right? You're like, which one is it going to be? Let me put it into a statement for you. You have to be at least 16 years old to drive a vehicle by yourself. Okay? So what would be some acceptable ages that you could drive a vehicle by yourself? 17. What else? 20. 18. All those acceptable values, were they more than 16 or less than 16?
More.
They were more. So at least means greater than or equal to. In this statement, it would be all ages have to be greater than or equal to 16. If you're less than 16 and you get pulled over and you're driving a vehicle, you're in big trouble. I don't know what happens, but it's not good. It's not legal. Okay? You have to be at least 16 years old to drive a vehicle by yourself. Okay? So at most. Okay, so let's talk about little kiddie roller coasters. A lot of times when you go up to a little kiddie roller coaster, it would say riders can be at most 48 inches tall to ride this ride. So now, what would be some acceptable values for the heights of your riders?
32.
No. Yes. 32 inches. What else?
47 and a quarter.
47. Anything. Okay, so at most means all heights of the children have to be less than or equal to, in this case, it was 48 inches. Okay? So your X in the statement, guys, is really important. This is on your homework tonight. It stands for all of the acceptable solutions. Okay? So on the first one, my acceptable ages for drivers had to be more than or could be equal to 16. All right? So at least and at most, those are probably the 2 most confusing terms. All right? Okay, so now let's go back to our inequalities. -4 is at least twice a number, which will stand for K. So we see at least here. Well, we just learned what at least means. Which symbol means at least? Greater than or equal to. -4 is greater than or equal to twice of K. Don't know what K is. All right. Do you see how we're doing that? That's the first 3 questions that you have tonight on your homework. Okay?
Exact questions?
Huh?
The exact questions?
No. But you're writing the statement as an inequality. Okay? All right. Example 2. Now we're going to test solutions. Okay? So we already know that there can be infinitely many solutions. So what we have here is we have an inequality, and it says, take this number and see if this is going to be a solution. Just see. Okay? So let's plug it in. -6 minus 2, is that in fact going to be less than -1?
Yes.
What is -6 minus 2?
-8.
-8 is less than -1. Is that a true statement?
Yes.
So, because this is a true statement, you will say yes, negative 6 is a solution. Because this statement was true. Okay? Negative 6 is a solution. Because when I plugged it in, it made the inequality true. Okay?
What?
Huh?
Within what?
I plugged in negative 6 for C. And when I simplified it, this statement right here is a true statement. Negative 8 is less than negative 1.
Okay,
So-
the section on the right is its own problem?
Yeah, this is the second problem.
I was
Okay,
confused.
so now, yeah, these are two different problems here. So now I want you to test the solution of x equals 2 when 2x minus 15 is greater than negative 4. Okay, 2x minus 15 is greater than negative 4. Go ahead and test that solution when x equals 2. So let's plug in 2 for x. Okay, so we have 2 times 2 minus 15 is greater than negative 4. Okay, well, what is 2 times 2? 4. What's 4 minus 15? Negative 11. Is that true that negative 11 is greater than negative 4?
Yes. No.
No, it's not. So 2 is not a solution because when I plugged it in, it did not make the inequality true. Okay, when I plugged it in, it did not make it true. Any questions? Any questions? You have a couple of those on your homework. Okay? All right, graph the inequality now. Before you can graph an inequality, you have to make sure that the variable comes first in the inequality. So look at A. Does the variable come first in the inequality? No, it doesn't. Okay, so you want to make sure it comes first. Otherwise, when you look at this, don't you think this is a greater than sign when you look at it? But it's actually not, because you have to read the variable first. So when you see the variable come second, I want you to rewrite it. Do the G first. Okay? Now look, do you see how the inequality is closed off towards the G? Do you guys see that? When you rewrite it, the inequality has to stay closed off towards the G. All right, then you have your 5. Now read this inequality. Read this one. G is less than or equal to 5. So remember what we said for the variable. Do you remember we said all numbers? Remember we said all numbers? All numbers, let's read it together. All numbers less than or equal to 5 will make the statement true. Okay? Will make the inequality true. So I need to show that on a graph. All right? You don't necessarily have to say the all numbers part, but I'm just kind of showing you. All right? How does that look on a graph? It's a number line. Look, that messed up. Okay? Whatever the solution is, pay attention. Okay? Whatever the solution is, G is less than or equal to 5, that number goes in the middle. Okay? That number goes right here in the middle. What value is just 1 unit less than 5? What number? 4. So you're going to write that to the left of 5 because 4 is 1 unit less than 5. What's 1 unit more than 5?
6.
6. All right. I want 3 numbers on all of your number lines. Okay. So that kind of gives you the parameters around whatever your solution is. Okay. Now you need to decide what an open dot or a closed dot need to be plotted on the 5. The inequality sign will tell you, look back up to the top of your notes. Which dot, the open dot or the closed dot, belongs when you have the equal to bar underneath?
Close.
It's a closed dot, which means that 5 can be a part of the solution. So you're going to do a closed dot on the 5. Closed dot on the 5. Okay? Now, which way does my arrow need to go? Now, your arrow points the reader in the direction where all the answers would be. Every number that would be a part of this solution. So what did you say when you read this? You said all numbers what? Less than or equal to 5 will make it true. So that means you must draw your arrow showing the values less than or equal to 5. Less than left is how I like to remember it. Less than left. And then draw your arrow on the end of that line. Okay? You probably have done inequalities at some point in the past. 8th grade is not supposed to be, at least, the first time that you learn inequalities. Okay? Thanks to COVID last year, the year ended kind of weird, so you may or may not have covered it. I don't remember. Okay? All right, so now look at B. B is greater than -8. Is this solution ready to graph? Is it in the correct order? Yes, okay, because I want my variable first. So this means all numbers greater than -8 will be a solution. All right, I want you guys to try to get this on your number line. All right, try to get this on your number line. You need 3 numbers. I'm going to give you a minute. I want you to try to get these numbers on your number line. Okay, be careful with your negative. All right, what number goes in the middle? What number is 1 unit less than -8?
-9.
-9. Good, guys. Very good. It's farther from 0, so my negatives are getting larger in number but smaller in value. What about to the right?
7.
-7. Okay, everyone together. Open dot or closed?
Open.
Open, because there is no equal to part. -8 is not a part of the solution. But which way would my arrow go?
Right.
To the right. Okay, you guys are doing really well on this. All right, so we just kind of make that line more shaded in. And the most important part is that we want to draw the arrow on the end, showing that our answers go off into infinity and beyond. Okay, no, yeah. All right, what movie is it from? Come on. Toy Story. I watch that movie at least a couple times a week, thanks to my children loving that movie. It's a great movie. Okay, so now let's go in reverse. Now I'm going to give you an inequality, and a graph, and I want you to write the inequality. Okay? You can use any variable you want. Okay? I want you to write the inequality that represents the graph. All right, Connor, you want to give it a shot?
G is less than or equal to 1.
Okay, so he said G is less than or equal to 1. How did he know it was supposed to be less than?
Because the arrow's going left.
Arrow's going left. How did he know it's supposed to be equal to? Because it's a closed dot. How did he know it was a 1? Because it's on 1. Okay? Did you guys get that?
Yes.
You guys have any questions? Now, you're probably going to have some questions on homework. We'll kind of go over those questions as they come up. But we'll go ahead and start the big ideas homework. And if you understand that, that's everything you need to know for day 1.